multiplication by using Antyayordashakepi sutra. Antyayordashakepi sutra for multiplication is specific method and is used only when following two conditions are satisfied. Friends, this is specific method of multiplication and can be applied only when given numbers satisfies following two conditions. What is first condition? For the two given numbers, okay, sum of the last digits of the numbers to be multiplied should be 10 or its powers, and remaining higher digits in both the numbers should be identical. For example, see 1 7 and 1 3, that means 17 multiplied by 13. See, first condition, sum of the last digits of the numbers to be multiplied should be 10 or its powers. See, sum of the last digits 7 and 3. 7 plus 3 is 10. Sum of the last digits of the given numbers should be 10. Here 7 plus 3 is 10. So first condition is satisfied here. What is second condition? Remaining higher place digits in both the numbers should be identical. See, here it is higher place, okay, write higher place here. Remaining higher place digits in both the numbers should be identical. See, in the multiplicand there is 1 and in the multiplier also there is 1 at tens place digit, okay. That means second condition is also satisfied. So we can apply Antyayordashakepi sutra for the multiplication of these two numbers, right? So let us read algorithm now. First step is multiply the digits whose sum is 10 or its power and write the product in right part. Note that number of digits in the right part should be equal to twice the number of zeros in the sum. See, let us understand this algorithm by same example. 17 multiplied by 13. See, 17 multiplied by 13. See, first condition is satisfied, 7 plus 3 is 10, and second condition is also satisfied because higher place digits in both of these numbers are identical. There is 1 in the tens place of multiplicand, that is 17, and there is 1 in the tens place of multiplier, that is 13. So we are going to write the answer in two parts. See, this is right part and this is left part, correct? Multiply the digits whose sum is 10 or its power and write the product in right part. See, 7 multiplied by 3. Multiply these two digits whose sum is 10 or its power. In this case, 7 and 3. So 7 3s are 21. Write 21 in right part. Okay. What is second step? Multiply the identical digit or digits which are at higher place to its ekadhik. What is ekadhik? What does it mean by ekadhik? Ekadhik means by one more. One more. Ekadhik of 1 is 2. Ekadhik of 2 is 3. Ekadhik of 3 is 4. You have to add 1 to the number or to the digit whose ekadhik is to be calculated. If you want to calculate the ekadhik of 5, add 1 to 5. You will get 6. So 6 is ekadhik of 5. So multiply the identical digit or digits which are at higher place to its ekadhik. What is ekadhik of 1? 2. So multiply 1 with its ekadhik, that means 2. So answer will be 1 2s are 2 and 21. Now condition is, important note is, see, important note is, note that number of digits in the right part should be equal to twice the number of zeros in the sum. Okay, what is sum? 7 plus 3 is 10. How many zeros are there in the 10? Only 1 zeros. That means we need 2 digits in the right part. Twice the number of zeros. Number of digits in the right part should be equal to twice the number of zeros in the sum, which we already have, right? We need 2 digits here in the right part because there is only 1 zero in the sum of these 2 digits, last digits. But if there is only 1 digit, Then what to do? Simple. Write 1 0 at the left side of existing digits in the right part. See, I repeat, write 1 0 at the left side of existing digits in the right part, so that number of digits would become 2. Simple. Let us repeat the algorithm. Step number 1 is multiply the digits whose sum is 10 or its power and write the product in right part. Note that number of digits in the right part should be equal to twice the number of zeros in the sum. That means 10 or its power. Step number 2 is multiply the identical digit or digits which are at higher place to its ekadhik and write the product in left part. So friends, let us solve these 7 examples.